review day from something you've done before. There's maybe one piece that we're going to do a little bit differently than you've done in the past. So we're talking about systems of equations. Do you guys remember what a system of equations is?
I remember the name. I don't remember what it is. Like this.
Okay, when you have multiple equations.
The substitution and all that?
Mm-hmm.
What's the other one?
You probably, well, by graphing, but we won't really do a whole lot of that. So, when we're talking about system of equations, that's two or more equations that we have at the same time. The solution is like an ordered pair that makes them both true. We have two situations. If you have a solution, that is called a consistent system. So if it has a solution, it is consistent. In terms of a graph, you mentioned graphing is one of the options for solving these. If it's consistent, you're going to graph your two lines and they meet somewhere. I said at least one solution. How could it have more than one? Okay, could I give you two equations for the same line? Yeah, so that every point on that line would work. So that would be another situation where it's consistent because you get an answer. We will also in this chapter talk about nonlinear systems. So we might be looking at like a parabola and a line. So a parabola and a line could meet more than once. So we will have situations where we have one solution, two solutions, or maybe an infinite number if they're the same line. If it has no solution, we call it inconsistent. What would it look like if there's
that parallel?
Yeah. The only way those two lines would never touch is if they are parallel. So in general, we're just going to solve it. In the situation where we have no solution, I will expect you to write no solution and inconsistent. And the directions will tell you. Identify any inconsistent systems.
We're going to put the solution as inconsistent for the other one?
I won't make you write consistent, so just the solution.
Weird.
Alright, so let's review the two main strategies, substitution and elimination. Graphing was an option, but that isn't always the best because sometimes the points where they meet are not nice and that's hard to tell from a graph. So we aren't really going to rely on that one. If I tell you substitution,
Set 1 to 0.
not to 0, but you get take one of the equations and solve for one of the variables. It doesn't matter which equation or which variable. So, okay, so if we take the second one and add my y. So x is 4 plus y. Then what do you do with that? Okay, I substitute that into the other equation. You have to make sure it goes into the other one. So for the x, I'm going to use 4 plus y. That's y equals 8. And so now we solve this. So y plus y is 2y. Subtract the 4. Divide by 2, so we get y equals 2. Then what? Okay. I know x equals 4 plus y. So if y is 2, 4 plus 2 is 6. And then how do I want you to write the final answer? xy. So 6, 2. If your variables aren't x and y, like I could give you a's and b's, you just put them in alphabetical order when you list it.
Do we have like checker answers?
Yes, you can check your answer. Now, they should work if you've done all your work correctly, but to check it, we just plug them in. So 6 plus 2 is 8, and 6 minus 2 is 4. So it works. So use substitution to solve this one. So you can get it by any of the equations, but perhaps easiest to get y by itself in the first one if you want to avoid fractions. So that means y is 5 minus 2x. Since I used the first equation, I'm going to sub it into the second. So negative 4x plus 6, and instead of y, I use my 5 minus 2x equals negative 2. So if we distribute, so I get negative 16x. If I subtract my 30, equals negative 32. So x is 2. Do you have to get integers on these? No, fractions are fine. They can happen. So then I just have to plug this back in. So I have my x. I'm going to plug it into this equation. So y is 5 minus 2 times 2. So we get y equals 1. So my answer is order pair 2, 1. And if you check it, 2 times 2 plus 1 is 5. Negative 8 plus 6 is negative 2. So it does work. Does anybody need me to look at theirs if you did it differently and got a different answer?
Not gonna lie, I got like 4 over 13.
Can we look at it?
Nah, I'll figure it out. Do I answer them?
Magic. Magic happens. So, right there, when you're solving for x, if you subtract that over, you get negative 4x.
Oh, word. I make it even more ugly.
Yeah.
I'm glad I didn't do that.
Okay. Let's talk about the other option, elimination. So if I gave you this equation, elimination, our goal is to be able to add these equations together to eliminate a variable, to cancel out one of the variables. Now to do that, if I just go and add these equations right now, it's not going to get me anywhere. So I have to first pick what variable I want to eliminate. So do you want to get rid of x or y?
Y. Should be negative 6.
Okay. So if I wanted to get rid of y, this is a positive 6, so I just need the top one to be negative 6. So all you have to do is multiply by negative 6. If I'd wanted to eliminate x, what would you do? Okay. So if I multiply by negative 6, I get negative 12x plus negative 6y equals negative 30.
Why did you put plus negative 6y?
I don't know. Sometimes you might have to multiply both equations by something in order to get them to cancel, and that is also an option. So it doesn't have to just be one equation. So then we're going to add these together. So negative 12x and negative 4x is negative 16x. Negative 6y and positive 6y would just give me a 0, so those go away. Negative 30 plus 12. So then what?
Be negative. Be positive 9. You got by 16.
What?
Okay, so I did get a fraction here. Just a little caution against using decimals. A decimal is fine as long as you're not rounding it. But if you round your decimals, it will throw off your answer. So just easier to keep it in fraction form. So then, what do we do? Okay, does it matter which equation? Alright, so if I put it in the first one. So 2 times x, which is 9 over 8, plus y equals 5. Okay. And then we subtract that 9 over 4 over, and we get 11 over 4. Hmm? And then, could we check these if we wanted to?
Yeah.
Yeah, you just plug them into both equations and make sure it works. Alright, is that one okay? Let's do, what if I gave you this one?
Multiply by 2.
Okay. I didn't say that you had to do substitution or elimination, so you could pick here. Elimination is usually the preferred method. So when we're trying to decide how to get there, you'll notice it is set up slightly different than the other ones. What did I change?
You said equal.
They're equal to 0. I didn't move the constant to the other side. If you don't like that, you could move it over, but you don't have to. So why don't you guys, can you do this one by elimination? Alright, so this is one where you have to really multiply both equations by something. If I wanted to cancel, what'd you guys do? X or Y? X. If I want to cancel X, what did you multiply the top one by? Alright, so if you're canceling X, you take this one times 5 and this one times -3. If you want to cancel Y, you'd have to multiply by 2 and 3. So I get 15x minus 30y minus 10 equals 0. And -15x minus 12y plus 3 equals 0. So when I add those, cancel. So -42y minus 7 equals 0. So -42y equals 7. Divide by -42 and you get -1/6. Then we plug this into either equation. So if I put it into the first one, so we get 3x plus 1 minus 2 equals 0. So that's a -1. If I add it over, a positive 1. So x is 1/3. So my answer would be 1/3 -1/6. All right. So far, so good? All right, let's solve another one. Okay. Any method, substitution, elimination, I do not care. If I asked you to solve this.
That's not
So, what did we do?
you -2, but then that cancels out those variables.
Alright, so if I multiply by -2, we get -4x minus 2y equals -10. Okay, so you'll notice -4x and positive 4x cancel. -2y and positive 2y cancel. So that gives me a 0 equals -8 or -10 plus 8 is -2. 0 is not -2. So it's not the fact that both variables cancel that make it inconsistent. It's the fact that this is a false statement. 0 does not equal -2. So in this scenario, your directions will tell you that you have to identify any inconsistent systems, but we also need to give the solution. What is the solution here? No solution, inconsistent. And you have to give me both pieces there. That means these lines are parallel. If you graph them, those two never cross. following it like normal. So substitution or elimination, what do you want to do?
Multiply by 24. Elimination for sure.
So if I wanted to cancel my x's, what would I have to multiply by?
Try. Wouldn't it would be,
Okay.
6.
So
18.
if you multiply, okay, if I wanted to get rid of the fraction, what would I have to multiply by? A 3. And then I need it to be a 6, so 6 times 3 is 18. So I could multiply it by 18. If I wanted to cancel my y, it's going to be 18 also. Let's look at this.
And then if you wanted to cancel your constant.
So 1/3 times 18 is 6. 1/6 times 18 is 3. 2/3 times 18 is 12.
It's the same thing, bro, for no reason.
Yeah, but this is a true statement.
Okay. So when I go to add these, my x's cancel, my y's cancel. So I have 0 equals 0. And that's true. There are infinite solutions. So your directions will specify how to write your answer. Last year, I think you probably just wrote infinite solutions and left it at that. We are going to be more specific because it's not just every ordered pair I pick, it's the ordered pairs that fall on this line. Okay, if it says to write it with y arbitrary, that means we are going to put everything in terms of y. So our ordered pair x, y is like normal. Then I have to solve for my x. So take one of your equations and get x by itself. So what would I do to get my x by itself?
Plus 3 over.
Okay.
Was that funny?
Yeah, it was down like here.
And then what would we do? Okay, so -12 divided by -6 is positive 2. 3 over -6 is negative. So for my x, I'm going to put 2 minus 1/2 y. So this describes every ordered pair that falls on this line.
Is it always gonna be like that? Like the y is gonna be.
It could be x arbitrary. If I said x arbitrary,
we just do the same thing.
then your ordered pair x would be normal, and then you solve for y. So whatever variable is arbitrary is the variable you keep. You get rid of the other one. Alright. Gonna give you guys a problem, and then we'll probably be done for today.
Wow, was it?
I know homework today. One of the refs came up, or one of the moms came up to me, and he's like,
Alright,
girlfriend.
so if we multiply the top by -2, we get -2x minus 4y equals -8. And then we have the positive 2x plus 4y equals 8. So when you add these, you get 0 equals 0. So what does that mean? It's consistent. There are infinite solutions. I asked for y arbitrary. So we keep the y, and we have to solve for x. So probably easiest in the first one. You can just subtract your 2y over. So you get 4 minus 2y comma y. Is this good? Alright. So I'm done for today. There is a Math Excel assignment and probably enough time